Hi, Assalamualaikum and welcome back to Dynamics ECS 429. Okay, class, how are you? Can you see my screen now?
Yes.
Yes.
Boleh.
Okay. Okay ke test hari tu?
Okay.
Okay, Alhamdulillah seronoknya dengar perkataan okay tu. Alright, okay, so I'm hoping you're gonna do well for test 2 also. But maybe for test 2, because the percentage is higher, 40%, we need to work harder. We need to do more exercise, okay? All right, and you need to ask more questions, okay? Because I don't get any questions from you guys. I'm not sure, not many questions, okay? But I hope you will ask more questions afterward lah. Okay, so can you see my screen? Can you see my screen?
Yes.
Okay, now for today's class, I'm going to start beginning telling you about the overall things that we're going to use for rigid body, formulas and everything that we're going to use for rigid body. So for rigid body, we're going to start using a lot of example, a lot of equations of moment of inertia, which is I lah. I is moment of inertia. Okay, so for moment inertia, there are many types of examples because the moment of inertia differs based on the shape, the size, okay, it's different, okay, for each item. Okay, somebody just join our group. Okay, right. Okay, Mustaqin, you are late. Okay, you can see my screen, Okay, all right. So for moment of inertia, the formula is I, and there are many types, I disk. Okay, there is I disk, which is the formula is 1 over 2 mr squared. Okay. Okay, ada ke yang baru masuk lagi? Baru masuk. Okay, kenapa lambat? Muhammad Zakwan. Okay, alright. Okay, so we have a number of types of apa? Sorry, dah jatuh pula buku ni. Sekejap Okay, so kita ada number of types, which is I disk, and we also have I rod. Okay, so if we're talking about I disk, it means M is the mass, R ni adalah radius lah. Okay, and then we also have I rod. I rod is 1 over 12 ml squared. So let's say you have a rod, panjang rod ni macam ni. So this will be the L lah. Okay, all right. And then we also have another type of circular eye, which is I, also disk, but the formula is mk squared. Okay, this one you only use this formula, only use this formula when when given k equals to radius of gyration. Okay, so what it means is for another IDs, which is also circular and also have R, but if the question give you radius of gyration, maksudnya dalam soalan tu dia kata given radius of gyration K equals to 2 meter, K ni bukan stiffness K ialah radius of gyration, you kena guna formula MK squared. Tapi kalau dalam soalan tu dia did not mention anything radius of gyration, you must use the formula 1 over 2 mr squared. So kita ada IDs, I rod, semua ni lah. Okay, alright. Now, The other thing, if the if formula for moment of inertia is at the center of gravity, this is the formula lah. Tapi if the question is not on the center of gravity, it means another point. Okay, for example, I give you example. Let's say this is your rod. Okay, this is your rod, and you punya rod ni, let's say for example, this question, okay. Let's say for example, dia punya center of gravity here G kat sini. Tapi dia ask you to calculate moment of inertia dekat point sini. Let's say this is point O. So when the question asks you to calculate the moment of inertia at a different point, the formula for I rod, maksudnya dia ask you to calculate the moment of inertia I rod at point O lah. Formula dia jadi 1/12 ml squared plus md squared. Okay. So ada additional formula lah. Okay. So apa tu D? Okay. D tu adalah sebenarnya Y bar. D ni adalah Y bar. Okay. I rasa you're familiar of Y bar lah. Okay. So nanti kita akan buat satu soalan yang berkaitan dengan menggunakan formula ni, and you will understand better lah. So this is moment of inertia lah. Okay, now, so basically why is moment of inertia is important? Okay, because it actually calculates the resistance of the body due to angular acceleration. Okay, so moment of inertia, what it does is so moment of inertia, the purpose, it measures the resistance of the body. Okay, you measure the resistance of the body of a body to angular acceleration. Okay, all right. So this is the purpose lah. Okay, what it does. So usually, what we do is we compare it with moment of inertia. So the formula for moment usually is m equals to I alpha. Okay, so this is one important formula lah. Okay, but maybe this formula we're going to work on it next week. No, on this Thursday kot. Tapi at least I introduce to you now lah. Okay, so what is the difference between this formula and this formula? Okay, so basically this formula M equals to I alpha, dia measure the resistance of the body due to angular acceleration. Kalau F equals to MA, which is the Newton's second law, dia measure the apa? Dia measure with respect to acceleration. This one is due to acceleration. Maksudnya dia measure the resistance also, but due to acceleration. Kalau ni moment ni dia measure the resistance but due to angular acceleration. Okay, alright. Alright, so at least you are clear about this part. Okay, now next when we go into when we go into detail about the topic, you akan nampak lah kegunaan dia lah. Okay, now next slide. Are you okay, guys? Did you manage to copy that slide? This slide? You copy tak?
Copy.
Copy. Alright. Okay, you're here, you're not in another class doing something else ke apa kan? Okay, now. Okay, so now you know the existence of moment of inertia. Next, the other important things. Okay, now I'm going to give you the overall picture of the overall formula for topic rigid body. For rigid body, of course, free body diagram, you must equal to kinetic diagram. And then this is number one. Number two, we're going to use summation forces Fx equals to effective Fx. Okay, Fx effective. Summation of Fy equals to effective Fy. Okay. These are all the important things that you need to be alert there. And then we're going to take moment. So moment effective. Okay. Don't worry, when we go through the topic, you will see all the important things. So other things that are important, you know, the formula for velocity is r omega. And then formula for acceleration due to tangential is r alpha. And then acceleration to normal is r omega squared. So we're going to use all this. And then we also have work and energy for rigid body. So for work energy for rigid body, the formula is the same. The principle is the same. Kinetic energy equals to work equals to kinetic energy. However, the formula for kinetic energy, previously, what was it? 1 over 2 mv squared, right? But now you have an additional formula. What is it? 1 over 2 I omega squared. Because now we are in topic rigid body. Bila rigid body ni, there is a possibility ada rotation. Okay, bila ada rotation, you kena consider I omega squared. What I'm trying to say is, you remember the type of motion that can occur in a rigid body? Dia boleh ada apa? Ada 4 kan? Satu, translation in rectilinear rectilinear motion, betul tak? Do you remember?
Yes.
Translation in rectilinear motion. Okay. And then we also have translation in curvilinear motion. Okay. And then we also have rotation. So it means in the question you have to identify what kind of motion. There is a probability you only consider 1 over 2. There's a possibility you only consider 1 over 2 mv squared because it's only moving in a straight line. Okay, but there's a possibility that you have to consider rotation as well. It means in the formula for kinetic energy, you have to look at the question whether you want to consider both or just either one, or only 1 over 2 I omega squared. It depends on the question. You have to decide. Okay, because in the question you have to see what kind of motion is involved, and then you decide either you want to consider either one or both. If both, what is it called? Remember, there's one more.
General plane motion.
General plane motion. So they can they can also happen at both instances. So that's why you have to decide whether you want to consider both or only one of it. But don't worry, when we start doing question, you will see that, oh, for work energy, we only consider the rotation. So you only consider 1 over 2 I omega squared. Okay, but we will see that. And then we have another one is linear impulse and momentum. So linear impulse and momentum, it involves time. So the formula is linear mv1 plus impulse equals to mv2 lah. Ini ialah the linear formula lah. Yang ni adalah kinetic energy lah. So for the linear one, if you are considering rigid body, dia punya linear ni L lah. I buat linear L lah. Linear L, dia akan jadi mv plus, what do you think? I omega. Okay. So ada I omega. Jangan silap Yang ni, yang work energy is 1 over 2 I omega squared. Kalau for linear is I omega. Okay, mv plus I omega. Okay, all right. So what are the other important formulas yang kita biasa buat sebelum ni? Just to recap, to remind you all, the other formulas kalau for linear apa, V equals to ds over dt, apa lagi? A equals to dv over dt. Masih kita gunakan ya untuk topik rigid body ni ya. V dv. Tapi kalau angular, this is linear motion ataupun we call the basic kinematic equation. And then kalau angular motion macam mana? You all remember kan? Omega equals to d theta over dt. Alpha equals to d omega over dt. And lastly, alpha d theta equals to omega d omega. Okay. And then lastly, kita ada motion with constant acceleration. You remember? Okay, I just remind you motion with okay, ni just a recap sikit so that you remember with constant acceleration kita masih menggunakan formula. Kalau linear kita pakai V equals to V naught plus ACT. Okay, S equals to S naught plus V naught. You all kena cekap because during the exam, you all tak ada masa nak belik-belik cari-cari formula tu. That's why masa terbuang because baru nak mencari. So kalau you rasa masa tu tak cukup, it's because of that lah. So I want you all to be cekap lah. For angular, you know omega naught plus ACT. Okay. Theta equals to theta naught plus omega naught t plus 1 over 2 alpha t squared. And lastly, omega squared. I know you're tired writing this formula again, but just it's okay, we can write again. Okay, all right, so those are the important things untuk rigid body lah. Number one, kita kena consider moment of inertia. And then kalau calculate moment of inertia at a different point, you kena plus md squared. And then kalau moment of inertia of a disk, memang 1 over 2 mr squared. Tapi in case dia bagi tahu ada radius of gyration, you kena guna mk squared. Now, moment of inertia ada juga bentuk lain yang macam semicircle, square, macam tu. So, kena read the question. Sometimes they give you the formula of I untuk bentuk-bentuk yang berbeza ni. And then you kena calculate menggunakan formula tu. Make sure kalau formula I diberi, gunakan. Okay? Jangan tak guna. Alright? And then, moment equals to I alpha, and then F equals to MA. And then these are all the other important things. You kena tahu work energy and linear impulse. Formula principle dia sama. Tapi untuk formula kinetic energy ada extra formula 1 over 2 I omega squared. Untuk linear ada I omega. Tapi it depends on the question. Bukannya setiap kali question kena plus I omega, kena plus MV. Boleh jadi either one ataupun both. Okay, depends on the question. Okay, now, so since you understand that, maybe we can start and do one question. Are you okay? That is just the basic and overall lah. Okay, so basically, kita punya objective and learning outcome for today's class, basically kita nak learn how to determine I, moment of inertia, and then the second one, kita nak develop equation, kita nak determine, kita nak learn about force and acceleration for rigid body lah. Okay, so this is our main purpose for today lah, our class lah. So are you okay guys? Can we proceed?
Yes.
Boleh? Okay, alright. So, copy this question and then we can do it together. So, okay. Jangan malas-malas screenshot pen tu bergerak. Kita kena buat soalan ni together sama-sama Dah habis dah pun test 1, tinggal test 2 je dengan projek and then you all dah okay dah. InsyaAllah, I doakan you all semua lulus. So, saya harap you all dapat A, subjek dynamic ni. InsyaAllah kalau you all ada usaha, okay, understand the class and then start buat tutorial, you can really do well in dynamics Okay, it's not difficult all you need to do is listen, join the class, okay, ask questions if you do not understand, okay. Yang penting you all consistent. Okay, join the class every week, dengar apa pesara explain and then do the exercise if you don't understand. Okay. I know you are going to go and start having a lot of assignments. So if you work on your assignments very well, follow the rubrics, you will get good marks. Oops. Okay, copy dulu, lepas tu bagi tahu I after you have finished copying. Dah?
Dah.
Okay. The pendulum is suspended from pin at O and consists of two thin rods. So ada dua thin rod Rod OA, okay, ada dua thin rod So pertama rod OA ni. Okay, ni rod OA ni yang kuning ni. Okay, rod OA. Okay, rod OA has a mass of 12 kg, and then BC yang hijau ni, okay, yang BC ni has a mass of 9 kg lah. Okay, so ni 12 kg, yang ini 9 kg. Okay, now determine the moment of inertia of the pendulum about an axis passing point O. Now, bila okay, so because this is a rod, apa formula I rod? Tell me, guys.
1/12 ml square.
Okay, ml squared. Now, and then secondly, because dia bukan minta moment of inertia dekat point G, dia minta dekat point O, kena plus apa?
MD squared.
MD squared. So you understand guys? So you have to read the question carefully and see whether you need to add MD squared or not. Okay, alright. Now, so basically kita kena buat I rod, satu untuk rod OA, satu untuk rod BC lah, yang kuning dulu So yang kuning dulu ialah 1/12, the mass is 12 kilos, and then the length, berapa the length? What is the length of the rod? 2 meters, betul tak?
Betul.
Okay, squared. Now, the mass is still 12. Okay, D. D adalah what I said, Y bar. So, kalau D ni bahagi 2 and distance from half of the rod 2.0. So, what is the distance? This distance? Berapa? Berapa, guys? What is D? What is Y bar? Panjang ni lah. Panjang ni berapa? Panjang rod tu 2 meter. So, kalau Y bar, dia mesti, Y bar sama dengan apa? Half of the length sampai ke point O. Betul tak? So, berapa length ni?
1
Plus?
meter.
1 meter So, maksudnya D adalah 1 meter 1 meter squared. Okay, tolong calculate. And then we have to do for I rod juga, tapi for BC pula. So formula sama 1/12, mass is 9. But now what is the L, the length? Oh, lupa nak bagi. Panjang ni berapa? Tak payah bagi. Berapa panjang kita punya rod BC?
1,5.
Oh, ada lagu tu. Sambil dia dengar lecture kelas saya, dia pasal lagu. Lama. Kan? Okay, berapa banyak ni? 1.5 squared. Betul? Okay. Plus 9. Okay, now. Dia punya center betul-betul kat sini. Dekat betul-betul kat sini. So, center dia kat sini. So, sampai ke point O atas ni. So, berapa dia punya D? Agak-agak berapa? Kelas, D dia berapa? Hello, tolong bagi tahu.
2 meter.
2 meter juga. Okey, faham So, tolong dapatkan value ni. Lepas tu, jawapannya untuk I adalah hasil tambah lah. Dua-dua. So, tolong calculate. So, untuk I rod OA, jawapannya 16 kilogram meter squared. Unit tu kena betul meter squared. Okay. And then untuk I rod, jawapan dia adalah 37.68 kilogram meter squared. So kalau you tambah dua-dua, you akan dapat 53.7 kilogram meter square. Betul tak? Tekan kalkulator sendiri, cari. Okay. Right. Now, jika let's say saya bagi gambar lain sikit, saya bagi ni panjang ni to be 3 meters and this one to be 4 meters. Berapakah Y bar, let's say ni samalah O, A, B, C. Berapakah D untuk ni, untuk BC? Berapa D dia?
5.5.
Macam ni dapat D dia? 3 bahagi 2 campur 4, betul?
Betul.
3 bahagi 2 berapa?
5.
Okay. So, itulah cara nak dapatkan D Okay. Faham tak?
Faham.
Okay. Alright. Sekejap Okay, good. Okay, so cuba fikir macam mana nak jawab soalan B pula. Dapat dah? Tahu tak macam mana nak jawab C, bahagian C? C pula. Soalan B. Macam mana jawab? Tengah berfikir ke? Okay, soalan kedua dia nak the mass center of the pendulum. So basically dia nak the mass center of pendulum, dia nak IG lah. Okay, tapi sebenarnya kita dah ada dah I untuk keseluruhannya kita dah ada dah jawapan. Azim. Sekejap Okay, so sebenarnya kita dah ada I dah. Untuk I keseluruhan dia, kita dah ada I. So, kita kena cari IG. So, maksudnya untuk soalan B, kita dah ada I. IG plus MD squared. So, I dia adalah yang tadilah yang kita calculate tadi. Iaitu apa? 53, apa tadi? 53.7. Kan? Okay. So, ni 53.7. So, kita kena cari apa tu IG plus MD. Tapi D dia berbeza. So, D ni kita kena cari Y bar. Y bar untuk keseluruhan diagram tu. Ingat tak formula Y bar? So, Y bar untuk rod yang pertama, Y bar dia 1, mass dia 12. Untuk rod kedua, Y bar dia 2, mass dia 9. And then jumlah mass dia 12 campur 9. So, itu adalah Y bar dia lah. So, dapat 1.4286 meter. So, itu adalah D dia lah. So, kita masukkan kat sini 1.4286. So, kuasakan 2. So, daripada sini kita boleh dapatlah IG. So, kalau dia minta mass center of gravity, kita boleh dapatlah. Okay. So, jawapan dia dapat apa? Cos 10.8. Okay, ini kalau dia minta lah. Okay, alright. Tapi Ini kalau untuk pendulum lah secara keseluruhan lah. Okay. So faham? So kalau dia minta IG, di sini lah nak cari. Okay. So that's why you kena baca soalan betul-betul. Kenapa dia dekat atas tu? Okay, never mind. Okay, so ni dah settle lah. Okay. Alright. So boleh kita proceed dengan apa? Topik seterusnya untuk
Madam,
dapatkan force ya.
yang M tu total Yang IG tambah M tu total mass ke?
Yang mana yang
Saya
ni?
tak dapat. Yang 53.7 sama dengan IG tambah M tu.
M ni adalah total. Sekarang ni sebab kita total kan dia 9 campur 12. Berapa? 21.
Okey, terima kasih.
Okay. Alright, okay. So basically untuk today's class, apa yang saya nak ajar ialah nak make sure you tahu macam mana nak calculate I lah. Kenapa dia bertindih ya? Semua bertindih. Kelakar pula. Okay, never mind. Tapi you all dah salin tadi? Kan? Macam mana nak hilangkan tindih ni? Masya Allah. Taklah. Tapi yang penting apa yang I nak sampaikan hari ni ialah you all tahu macam mana nak calculate I. Okay? Sebab I ni macam saya cakap lah boleh jadi circular, boleh jadi rod, kan? Dan kalau circular tu ada bagi tahu ada K, radius of gyration, formula dia lain kan? Okay. So tapi for today's class kita buat yang simple yang rod. Okay. Tapi nanti you akan nampak ada banyaklah jenis yang berlainan yang mungkin yang half semicircle, ada yang square. So ada banyak jenis bentuk yang berbeza So at least you all bukan new sheet lah. At least you all aware dan tahu macam mana nak nak menggunakan formula I tu. Okay. Sebab kadang-kadang formula I ni mudah je. Markah pun satu je masuk-masukkan. Tapi selalu ada student buat kesilapan. Sama ada dia tak plus MD squared and macam mana dia nak calculate D tu dia silap. So basically apa yang saya nak tegaskan for today's class ialah jangan buat those careless mistakes lah. Okay, bila soalan tu mudah, kita patut dapat full mark tapi you not sure. Okay. So mungkin you boleh cuba carilah soalan yang calculate moment of inertia yang berlainan. Mungkin boleh ada soalan moment of inertia yang bentuk bulat tiba-tiba kat tengah tu kosong. So moment of inertia outer minus inner. So dia ada banyak jenis lah tapi somehow of course lah you need to know the logic, the sense how to calculate it and to proceed with your questions. Okay. Alright, so now kita nak proceed dengan our next part di mana kita punya learning outcome, kita nak learn about force and topic force and acceleration lah. Okay, topic force and acceleration. Okay. Okay, alright. Okay, untuk topik force and acceleration untuk rectilinear motion, kalau you are considering rectilinear motion, kita akan menggunakan formula ni summation fx equals to m a g x summation fy equals to m a g y and then summation moment lah. Summation moment mg equals to 0. So usually kita akan ke arah kanan positif, ke arah atas positif ataupun clockwise atau anti-clockwise positif. Ini hanya assumption Kalau you nak assume the other way around pun boleh. Okay, ini assumption saja. Okay, alright. And then ini untuk force and acceleration kalau rectilinear motion. Kalau curvilinear motion dah boleh agak tak? Kalau curvilinear motion, kita akan buat summation Fn, M A G N summation Ft equals to M A G T and then summation moment. Sorry M moment G equals to 0. Ni kalau untuk curvilinear. Tapi konsep dia samalah. Okey, saya tak pastilah arah Fn tu, Ft tu atau moment tu arah mana sebab dia bergantung kepada soalan lah. Okey, let's say kita assume dia macam ni positif, dia macam ni positif. Contohnya. Okey. So untuk today's class kita nak buat soalan force dan acceleration Okay. Alright, dah salin dah ni? Okay dah? Boleh kita proceed?
Boleh.
Okay, boleh Okay, now. So sekarang ni kita nak buat soalan force and acceleration menggunakan yang formula rectilinear yang tadi ni lah. Okay, kita buat Okay. So salin soalan ni Okay, tengah salin ke?
Ya.
Okay, after this question, kita boleh stop supaya boleh fokus untuk you all punya test lah. Tapi I need you to be focus in my class lah. At the time being, boleh?
Boleh.
Okay, lepas tu you all boleh study Sabar Okay. Dah. Salin dahulu. Lepas tu bagi tahu I after you dah habis salin.
Dah baik.
Ha. Oops. Okay. Alright. So the car shown has a mass of 2m. M tu apa? mg. M berapa? Value M? Mega. G and center of mass at G. So dia punya center at G. Determine the acceleration. So dia nak acceleration if the rear driving wheel are always sleeping. So dia kata rear wheel. Siapa tahu rear driving wheel tu wheel depan ke wheel belakang? And the front wheel are free to rotate. So dah bagi clue lah. Kalau front wheel to free to rotate, maksudnya A ni boleh rotate. And then wheel belakang ni always sleeping. Okay. Dia always sleeping tu. Okay. Sleeping, you faham tak apa maksud sleeping? Dia licin lah. Okay. Alright. So neglect the mass of the wheel. The coefficient of kinetic friction between the wheel and the road is UK adalah 0.25. Okay, now so kita first need to draw the correct free body diagram lah. Saya lukis balik kat sini lah supaya nak buat calculation kat sini supaya ada ruang. Okay. So ni G dia. Okay. Lukis balik. Okay, ni berapa? Okay. Alright. So number one kita kena buat apa? Draw free body diagram kan? Okay, kita draw free body diagram. So of course dia ada due to weight. Weight dia berapa? W equals to mg. So mass dia berapa? 2 mega. Mega tu apa? 10 kuasa 6 betul tak? Kali G 9.81. Okay. Apa lagi ada? Okay, dia ada sebab wheels ni dia ada friction. So dia ada normal force. So kita ada NA kat sini. Normal force dia, wheel dia. NB kat sini. Kat sini dia dalam soalan dia suruh neglect dia punya wheel punya weight kan. So kita neglect lah. Okay, dan kereta ni menghala ke arah sini. Okay, that's why saya lukis gambar passenger tu dekat depan ni. Bukan passenger, driver ni, nampak driver ni kat depan ni ya. Okay, so the next is ada coefficient of friction. Berapa dia? 0.25. Tapi dekat mana? Wheel A ke wheel B? Dia kata wheel A free to rotate. So bila free to rotate, maksudnya apa? Maksudnya tak ada no friction lah. Okay, wheel B dia bagi tahu apa? Dia sleeping. Dia ada friction tapi dia sleeping. Tapi because dia sleeping, walaupun arah kereta kita acceleration dia ke kiri, dia punya friction slipping tu menyebabkan friction dia arah sama. Okay, faham tak? Ini ada satu benda yang you all kena alert lah.
Letak tangan dalam ni.
Yalah, but you don't have, you selalu makan macam tu juga kan? You don't have to ni. Okay. Alright, understand guys? Boleh tak? Siapa yang tak faham bila saya tanya pasal sleeping ni? Siapa nak cerita? Siapa? Siapa yang nak bersuara tu? Ashraf Haziq? Will be sleeping. Sleeping. Bila dia sleeping, dia licin. Okay, tapi walaupun dia licin, dia masih ada friction. Tapi friction dia arah yang sama dengan acceleration. So dia ada, will be ni ada friction lah. Mu K and B. Boleh tak?
Boleh.
Boleh
Boleh.
Okay. Alright. So, now, tadi saya kata kita kena guna formula ni kan? Okay, so kita nak guna formula ni F M A G X F Y M A G Y and then summation moment G equals to 0. So let's say assume positive. Atas pula. Ini assumption saja. Kita assume positif ke kanan, positif ke atas and anti-clockwise positif. Kalau you lebih selesa assume positif clockwise pun boleh. Okay. Alright. Now, so cuba kita tengok. Okay, this one must equal to kinetic diagram. Ni baru free body diagram. Tertinggal pula nak lukis kinetic diagram. Kat mana nak lukis kinetic diagram? Boleh tak saya lukis kecil-kecil kat atas ni tapi assume nampak besar. Okeylah saya lukis besar-besar lah. Macam mana? Sepatutnya tadi free body diagram tadi patutnya equals to apa tadi?
Kinetic diagram.
Tertinggal kinetic diagram. So kinetic diagram ni dekat center gravity dia G kat sini. So kenapa saya lukis kinetic diagram dia arah sini? Sebab arah apa? Arah acceleration, betul tak?
Betul.
Selalu kita buat ke kanan kan, kita dah terbiasa kan. Bila ke kiri kita rasa lain macam pula kan. Tapi jangan rasa lain macam lah. Okay, so free body diagram equals to kinetic diagram lah. Ni kinetic diagram ni jangan lupa tak buat lah. Okay, so kalau kita kembali kepada free body diagram, okay, in X direction kita ada apa? In X direction. Apa yang kita ada in X direction? Class?
Friction force.
Yes, friction force. Okay. So friction force arah acceleration. Positif ke negatif?
Negatif.
Yes, negatif 0.25 NB. Sebab friction tadi berapa? Mu K 0.25 NB equals to MA lah. So sekarang ni kita punya positif ke kanan. So kita punya MA ni negatif ke positif? Tengok kinetic diagram. Kan kinetic diagram fx kita assume positif ke kanan kan. So sekarang ni kita punya MA ni kan ke kiri. So ini akan equal to negatif MA. Boleh tak? Are you okay guys? Boleh? Okay. Boleh tak?
Boleh.
Boleh.
So saya terus gantilah M tu berapa So M tu 2000 lah. 2000 kilogram lah. 2000 kilogram kali dengan A G. Okay. FY pula. Arah FY kita ada apa? Positif. Kita ada NA. Kita kita ada NB, betul tak? Apa lagi yang kita ada? Kita ada weight. So weight tu adalah 2000 lah. Okey, 2000 kali 9.81 lah. Okey, nanti semua dalam kilo lah nanti. Okey, equals to kosong. Okay, next kita take moment. So macam mana kita nak take moment at G? So semua forces ni yang bukan dekat point G kita kena take moment sebab dia ada distance kan. Moment sama dengan force multiply by distance kan. Okay, so kalau you tengok saya buat color orange Kalau kita tengok moment NA, kalau nak ke point G dia arah apa? Clockwise ke anti-clockwise?
Clockwise.
Clockwise. So bila dia arah clockwise, dia dan kita dah assume positive anti-clockwise, so dia kena negatif lah. Faham tak? Negatif NA kali 1.25. Cuba tengok NB pula. NB arah anti-clockwise. So dia akan jadi plus NB kali 0.75. Apa lagi? Friction force. Friction force dia clockwise. Dia clockwise ke anti-clockwise? Dia clockwise. So dia akan jadi negatif lah. 0.25 NB tapi kali tinggi ni lah. Kan? Sebab dia adalah dia punya force. Kalau macam ni dia punya distance kita kena ambil perpendicular. Betul tak? Perpendicular distance. Kalau force distance kena perpendicular. So that's why kita ambil 0.3 equals to kosong. Okay. So you dah ada 3 equation ni. Cuba dapatkan NA dengan NB dulu. Dah dapat tu masukkan dalam formula yang pertama ni untuk dapat acceleration. So tolong bagi I the answer. Okay, cuba kira. Okay, siapa yang dah dapat jawapan tolong bagi tahu. Lamanya? Siapa yang dapat calculate tolong bagi tahu apa jawapan yang you all dapat. Tak apa, salah tak apa, kita check je. Okay, tak apa. Anyone? Anyone get the answer? Siapa tu buka mic? Cakaplah. Jangan cry-cry. Kadang-kadang dengar bunyi mic tu buka. Siapa? Nabihan? Nabihan?
6.9
Nabihan, apa yang 6.9? Oh, betul?
NA.
Kilonewton. NB?
NB 12.7.
Betul. Acceleration?
Sekejap. Sekejap ni ke?
.59.
Betul? Unit tolong.
Meter per second square.
Okay, betul. Okay, so this is the answers So basically tadi apa you buat, you untuk jawab soalan ni you take moment dekat G kan. Sebenarnya ada second solution. Okay. Second solution tu you boleh buat, you take moment dekat point A. Kalau you nak take moment kat point A, you boleh dia lebih mudah lah. You akan dapat terus jawapan NB lah. So maksudnya untuk soalan jenis yang macam ni, you tak semestinya tak semestinya you take moment dekat point G. You boleh selain daripada take moment kat point G, you juga boleh take moment kat point A. You juga boleh take moment kat point B. Dan you akan dapat jawapan yang sama. Anywhere you take moment. Melainkan soalan tu dibagi tahu. Okay, kalau dia tak bagi tahu, you boleh take moment kat point A dan terus dapat jawapan pun boleh. So kalau you take moment kat point A, dia akan jadi apa? NB kali apa? Kalau you take moment kat point A, dia akan jadi apa? NB kali apa? Let's say ni positif. Kali panjang ni berapa? 1.25 campur 0.75 berapa? 2 kali 2. Lepas tu apa lagi? Apa lagi ada? You ada due to gravity, due to weight ni kan? Due to weight apa? Sebab dia ikut arah ni, dia negatif lah. So negatif 2000 kali 9.81 kali apa?
1.25.
1.25 betul. Okay, lepas tu apa lagi? You dah buat NB, you dah buat weight. Apa lagi you tinggal? Equals tu, itu je lah. Equals tu M. Mass dia lah. Mass dia apa? 2000 kali dengan AG kali dengan, ingat tak kinetic diagram tu? Lupa dah?
3.
Kali dengan 0.3 sebab tadi sebab kinetic energy tu dekat kat sini kan. So kita nak take moment dekat point A ni kan. So you kena kalilah panjang ni. Panjang ni berapa? 0.3. So inilah. So maksudnya untuk soalan jenis macam ni, you boleh tapi positif 2000 ni positif kan sebab dia ikut direction positif bukan negatif kat depan ni, positif So what it mean is you can try to solve the same problem but take at different points. Sebab nanti later on bila you dapat soalan dynamic ke apa in rigid related to rigid body, you kena think of where you want to take the moments and how to solve it. Macam tu lah. Okay, so that is for the today's class. So kita habis awal sikit. Okay ke kita habis awal? Awal sikit? Boleh? For today? Okay. Tapi nanti hari Khamis kalau kita ada kelas sejam, you all akan join tak? Ada test ke?
Tak, pagi tak ada.
Pagi tak ada. Petang ada. Tapi sejam je kan. Kelas tu penting sebab kelas tu sejam tu kita akan fokus banyak yang menggunakan ID semua tu lah. Okay, so kalau tak ada soalan kita can stop here. So basically you can write. Okay, tolong isi attendance sekarang dekat Evums. So for today's class I learn about moment of inertia and then I learn about force and acceleration. I learn apa yang you learn? You tulis lah what you learn. I make sure you're in class lah. Okay. You dengar in class. Okay. I learn how to take moments at different points, either at the center of gravity or another point. I learned that for calculating acceleration, we use equation, force and acceleration formula, Newton's second law, F equals to ma kan. Tapi kali ni kita punya point dia gravity lah. Macam tu lah. Okay. Alright, so tolong isi attendance for today's class and then once you fill in the attendance, you can leave this group lah. I will see you back this Thursday lah. Okay, alright. Okay. So I
Madam.
will stop presenting. Yeah.
Nak isi kat week 8 ke 9?
Okay, week 8 sebab you ada test kan?
Yes.
So for week 8, because you have a test, you tulis ni je. You tulis apa? You tulis I had a dynamic test examination in week 8 untuk dua-dua attendance. Maksudnya untuk week 8 tu you tak perlu apa? Ni lah. Sekejap saya tulis dekat group Okay. Saya tulis kat chat box. Dekat chat box ni you tulis ni je lah. Because week 8 adalah minggu test kan. So tulis ni je lah. I had a dynamic test examination in week 8. So maksudnya dua-dua tutorial dengan apa? Lecture you tulis ni lah. Okay. Tapi sekarang ni kita kat week 9 kan? Kan Myra? Kita kat week berapa Myra? Dayang?
Week 9 betul madam.
Week 9. So kat week 9 you kena cakap lah. Today I learn about how to calculate moment of inertia for different shapes such as rod dengan disc. Semua tu lah. And today I learn about how to calculate force and acceleration. Okay. Alright. So untuk week 8 you tulis I had a dynamic test and examination in week 8. Itu sajalah. Okay. So kalau you dah isi attendance, you boleh leave Okay, I will stop my recording now supaya tak panjang sangat nak download. Okay. Alright. Ada soalan tak yang nak tanya? Oh, stop recording kat sini. Sorry.